Hello my friends. Today we're gonna take a look at goodies which were sent to us by Statorworks, company who actually produce pretty cool servos which are I2C driven or replacement board for your servos if you want to keep your servos but make them much smarter. I actually don't know what's in this package. I think Statorworks comes up all the time with some cool and new ideas, and I think we have to take a look what's in here and then discuss with you how can we use. So let's quickly open this little package and take a look what's inside. Okie dokie, we have neatly packaged stuff. We're gonna just pull it out and remove the box. Oh, this is amazing. Alright, so obviously we have standard Servo Jaws over here. Those are probably 15 kilogram servos. They are already programmed by 0x08 address. They are driven by DRV8876, which is quite a beefy driver from Texas Instruments. So this is driven by different board than the previous one. So this is a little bit beefier board. This is amazing. Also, we're gonna test those in operation. Alright, also we have flexible power strips. So this is again really great if you want to connect multiple servos in chain. So that we have 3 flexible power strips. I think this is a very neat idea, and not many people come up with such a smart way of actually running multiple servos, but I think this totally makes sense. Okay, so a little bit more headers over here. Those are probably for those servos, and over here, also I'm not sure what this for. So this for, I assume, for that. So this is SMD mounted distribution board. So if you have I2C and several servos in close proximity, you can do something like that. Connect over here I2C, and for this JTAG headers just this way. Not JTAG. GST headers. Yeah, this is puzzling. I don't know what is this for. Have to inquire. Okay, so so they are SMD, not through hole. Yeah, I'm just what would be the purpose of this one? This is mostly like power, so like those 2 pins, and this is the power distribution board. I think this is the only the idea I have. So if you're gonna run your power separately, you can use that separately from the signal. So it's a beefy little PCB, really nice looking actually, I must say. So a little tiny one, it's actually neat too. So I assume. Okay, so this is probably to use through hole contact over here, like this way, and connect your wires over here. So solder wires right this, and keep your connector right here, and another wire can continue, essentially making it as a pass through, which is neat as well. So we have four of these SMD mountable or angle mounted GST connectors. Few distribution boards, really neat. Okay, and another really interesting thing is actually servo tester servos. So this thing, obviously I2C servo, allow you to control your servo or test your servo from this little board. So if you wanna program your servo, or if you want to actually test your servo, like power and position, and test how it operates, you can use this board instead of rigging some kind of microcontroller. So if you have a lot of servos you have to deal with, this is very useful rather than just constantly reprogramming your microcontroller or rigging some kind of microcontroller just to program your servos and test them. This is very useful. I think I'm not gonna actually. Alright, I try to create video how to use that, but I think Statorworks have a really nice video to show to illustrate how it all works, and I think it works really neat. But for my purpose, this is really great stuff. So we probably have to run something and see how those things works. So for example, you have to power up your servo through this pin and provide some power through those pins, connect your servo over here, and you would be able to actually control it. So this seems to me like a 7-bit representing I2C address, and you would be able to flip those. Nice. Those are really neat. I love this idea. This is great. So if you have something like that, you can just, use your binary to hex conversion and to program your servo accordingly. Yeah. So the only which is confusing a little bit, that 1 to 7 over here and 0 to 6 over here, so people may get confused, but actually have to use 0 to 6 address direction over here. Okay, this is standard servo stuff, which are cool. Those servos are actually pretty cool when I compare them with previous servo that I got. That this one have metal. How do you call it? Metal spline over here, which is actually really good, and just make it much more sturdy, and they're not gonna strip. Also, I'm curious what kind of gearing is inside. Is it metal gears or just plastic gears? Or sorry, it's highly likely these are the metal gears. How many bearings do they have? Or just washers, bushings, sorry, or there are some bearings in here. Right, this is really cool. So what we have here is to try to power this guy up. The only thing is I do not have such a GST connector. I have to MacGyver something in order to power it up, because I need to find something in order to connect it. Not sure what is this VPG here. It's interesting. This is ground, clock, data, and voltage. This is a very interesting way of putting it. And VPG. It's probably potentiometer kind of business here. Representing position potentiometer. It's the only thing I can think of. But yeah, that's a really neat idea. So if you're dealing with many servos, this is gonna be super useful for you. Curious if this thing probably will not handle multiple servos at once, because you have to pick the address over here. But if you have a chain of servos, you would be able to, for example, pick the address of the servo, control it, see it works, pick another address, and so on and so forth. So yeah, I won't be able to do simultaneous operation, but something to think about. Maybe instead of like having address, you can do like wildcards, and you would be able to address multiple servos within the wildcard. I don't know, that's just an idea. Cool. So before I continue shooting this video, I have to MacGyver something in order to connect power over here, and I think we need like 6 or 7 volts, because there is a little tiny regulator for the microcontroller over here, and the same voltage go for servo, and yeah, 6 volt probably would be more than enough. So I will MacGyver something and we will continue. Alright guys, let's try to play with this little board and the servo. So I'll try to attach, let's say, this spline here, just to see the rotation of the servo. Okay, maybe let's It's black on black, huh? Interesting. I prepared over here 6 volt 2 amp current limited power supply, and hope polarity here is not. Let me double check. So now when we have our servo and power attached, let's try to access it and test it. So servo address is 0x08, and in order to access it, we need to convert it to binary and do it in reverse. So in binary it's going to be 1000, but it's easier to go in reverse, so it's going to be 0001. And let's try. Yeah, so we can adjust power over here, and we can adjust position. So with low power, it's gonna slowly go from max position to min position and vice versa. On max power, it's gonna go with maximum speed from max to min. Essentially follow your pod. Which is amazing. And you can reprogram your servo. For example, right now we have a 1000, and we can convert it to, which is corresponding to 0x08. We can make it 0x09 by this. So now we're gonna hold this button, pick, and it blinked here, and now it accessed by different address. One would turn it back to 08, like which is here. It does nothing. So in order to bring it back to 08, we have to switch it back to 9, access it, then switch it back to 8, press the button, blinks. I don't know if it's confirmation or if this is, oh no, it looks like it's regularly blinks. Now it's accessible via 0x08. Easy peasy. So I think this is quite a useful tool for those people who are converting their servos into smart servos, because in order to confirm their proper operation and reprogram them, it will be so much easier than doing it with the computer, right? Connecting to your microcontroller, making little programs to adjust all that. This is really handy. This is essentially another microcontroller, but just specifically built for this particular purpose. I think this is very useful device. So yeah, you can test your servos, you can reprogram them. Quite useful. Kudos to Statorworks to creating such a little device. I think it's quite useful. So here we have another servo, which is state here the same 08 address, and really hard to make out is 8876 or 8676. It specifically says 15 kilogram servo. Let's connect it and let's see. It feels like it's slower on the max power. Sounds totally different. So I'll have to probably take a look at those inside and see what are the differences between this servo and that servo, because the text here seems to be the same, but I'm not sure if they are the same, so we have to double check that. So I've done quick disassembly over here, and what we have. Okay, let's remove those back plates, not to forget which one goes where. Alright, so I think we do have completely identical two servos. To the level they could be identical. Oops, sorry, that went off focus. So yeah, I think we have two completely identical two servo controllers. They have even a similar here code. Is in this particular case 2 red wires, but it doesn't matter. So I2CS03X and the same over here. And as we see over here, there is a microcontroller over here, and there is a Texas Instrument driver, right? So inside, those servos seem pretty identical, despite the fact the different wiring over here, but the potentiometers, actually I could be wrong. Those are two different servo. So I would like to have a comment from guys of Statorworks that this looks like a different servo. So sorry, my bad. My bad. What's gonna happen if we're gonna retain it? Yeah. Curious, this has 240 number, and this one over here has 216 degrees. Not sure what the heck that's supposed to mean on those encoders or potentiometers, but that's what we have. So those servos probably are different, but they look so similar. No, okay, so I might be mistaken, but controllers over here are the same. So controllers are the same. Okay, so now let's just take a older controller and just let's compare them, and we see already quite a substantial differences. So layout is a little bit different. Alright, so pads are in the same place, but some elements are missing and some extra elements are added. And as you see over here, this big guy is a driver, DRV 8676. This is really hard to make out over here. I need like a microscope to actually see what's on this chip. So this is substantially beefier driver, and I'm gonna show you specs right here in the video because I don't remember them off the top of my head. As you see, there is a larger diode over here, a little bit different layout, and obviously the bigger die. So microcontroller highly likely is the same, and the part over here around microcontroller, it didn't change much, unless I'm mistaken. Who's... yeah, 8676 is this little guy over here. So yeah, that's correct. So yeah, I would like to know the voltage and current levels of this driver, and obviously the voltage level and current voltage level is going to be applied to this motor. So you have to make sure your motor is capable of handling, like, 10 volts or something, because obviously having 10 volts gonna make this motor spin way faster. So this is another thing that because voltage gonna be applied directly to motor, whatever you provide over here gonna go to the motor. So if you apply like 6 volts, it's gonna be slower than when you apply 10 volts. But again, this is my theory. I'm gonna double check that. Also, I'm not even sure what voltage this board can take, so I have to take a look at the driver over here. Sorry, not driver. It looks like this is a voltage regulator. So some voltage regulators cannot handle, for example, like, I don't know, 12 volts. They probably have a level of 9 or something. I just making up stuff here because I didn't take a look what kind of voltage regulator we have over there, just to make sure I'm not gonna blow anything up. And also I'm not sure what's the limit on this board, because this guy, the little guy, has another voltage regulator here to actually power a micro over here. So so this voltage regulator may have some input voltage restrictions as well. Some voltage regulators can be 35 volts, but some can be like 12 or so. So yeah, I do not know. Okay, it's not from here. Let's put this little tape back where it used to be and just pack everything up. Am I able to pull this drivetrain? I'd like to see. That's not the part of this video, probably, just to look in the gear. Oops, I need to move this spline off. This is all 100% metal gear servo, which is neat. This is nice servo. I like it a lot. Okay, this gear is supposed to get, it's really well lubricated. One bearing for sure, and really hard to tell if there is a second bearing. on the motor shaft or a on the encoder power shaft. It's definitely, I don't think it's going to be bearing over here. Yeah, it's going to be just bushings, like this one. Like you see this bushing over here, and it's nice. I'll try to open another servo as well. Hello, hello, come back. Oh, okay, so you have to like wiggle this thing, and then it goes back properly. So I'm gonna assemble them in their original shape, and we try to play with them more. And also I forgot to take a look closer over here on this board, but I don't think there is much going on here. It's just only one microcontroller, two encoders, this pin array or switch array, and a button, and yeah, how do you call it, a little voltage regulator. I think voltage straight from this goes straight to the motor. I don't think it does any other voltage regulation. Yeah, totally looks like it is. So look, the plus is exactly connected to V over here. So yeah, there's not much really to talk about this one. Obviously all smarts are in this microcontroller firmware. Alright, so I think we're good on this front. Let's just glue the sticker back on. Hope the gears didn't... No, it's all good. Let me put it all together and we can continue. Okay, so first of all I want to say, while I was fiddling with the servo to put it back together, I broke one wire, so that's easy fix. Not gonna put it in original shape because I need to resolder it, so it's gonna put it to the side. And let's just power this little guy over here and attach it to our controller and power supply, and try to fiddle with... Yay! Works as a champ. Looking good. I just noticed something else on this little board. Over here it has 3 pin for regular servo. I don't know what is PB3 and PB2. Yeah, I just noticed those over here. So potentially you can just attach regular Futaba or high-tech servo and just fiddle with it. I don't have headers for that right now. I would like to... Should I? Clearly it is connected over here. Over here is ground. Probably is it just a ground plane, or yeah, or just this trace, and yeah, and this one goes to microcontroller. So yeah, this is supposed to just power up a regular servo. The only thing what I do not know, unless it does it simultaneously over here and over here. Yeah, this is all I can come up with. Just, I'll be back. Haha, little quick mod over here, and let's see how it's gonna fly. And we have a little new guest over here. So this is regular servo, pulse width modulated signal over here. This is like Futaba connector. Alright, so let's try first. Obviously address is not gonna matter, polarity is important. Course. Wait a second. Oops. I think we have a problem. So yeah, it's the wrong pin out for regular servo. So regular servo has power in the middle, just to make sure people not gonna flip it and burn the servo. So power should be in the middle, signal on each side, either way. So if you flip it, you're just gonna ground pulse width modulated signal to the ground, so it's no big deal. So yeah, oops. I won't be able to test it because I do want to repin this guy. Well, I can, but okay, for the testing purposes. Guys, forgive me if you're gonna fry something today, but this is how it's gonna go. Okay, well, so this is plus, well, at least judging by, well, I did trace the, sorry, that's wrong. This is signal. Yellow is signal, and brown is negative or ground. Alright, so we have something like this. And I'll just power it up. Oops. Wire came off, power supply. It's very dinky wire. Whoa, whoa, whoa. It's sort of working! Let me reduce power. Power doesn't really matter actually, sorry. Yay! Well, I don't know, maybe it's not intentional, was not like it was not intentional as a part of product, or at least this is a test board. Pinout is clearly is wrong, and I think they know it, it just was not advertised, I think. But here's something. This is actually even more useful than I thought. Power, by the way, doesn't matter here. Yeah. Whoa, whoa, whoa. I just put it in the middle. Okay, let's do, okay, moment of truth. See what's happened. Hey! Ah, I see, it's smart. So if it detects some... Oh shit. Did they just kill it? Oh, I see what's happened. I think I just killed a little servo over here. What's happened? I think this little guy doesn't like 6 volts, sorry. Yeah. Well, yeah, I have a bunch of these. Yeah, this is, yeah, okay, so that was unexpected. This big guy, of course, works. This guy, I think, is Gonski. Yeah, it's okay. It's I have a bunch of these. It's no big deal. Sorry. Yeah, did you see the smoke? Magic smoke? Okay, let's... so what we're gonna do, we're gonna disconnect this guy. Disconnect this guy. Let's try it again to see if it's actually alive or gone. Unless it just shorted something here. Let's put power. Okay, power up. No. Power up, and voltage is gonna be... Yay! Someone is Gonski. Oh. Oh, too sad. I think I fried this little guy. So definitely, I'm not sure who's fried, motor or a microcontroller over here, but well, this is a candidate of transformation to our new servo. Yeah. Okay, well. Yeah, it's weird. What happened? I do not understand, but what happened, what happened. This is not that important. But probably there are some quirks here. So forget that I've done this. Maybe in new version there's gonna be more protection or something like that you won't be able to. I don't even know what happened. Probably 6 volt this guy doesn't like, but I think 6 volts should be fine with it. Anyways, this is probably not intended to be used, I guess, by design, at least for now. Maybe in different version. Yeah, this guy works as a charm. It's not a problem. So yeah, I didn't kill a board, I didn't kill the big servo, which is obviously, this is much more important to me. Anyways, sorry for this little magic smoke. It was stupid of me actually to fry it. I'm gonna take a look what's really happened. I hope motor didn't die. If motor thin die, I can, like, you know, try to fix it up or something to this extent, but yeah. Anyways, so what do you guys think about all this bunch of stuff I got recently? All these nice and beautiful strips, the distribution board, and those amazing servos, which are pretty powerful 15-kilogram servos with a beefy microcontroller. Also this wonderful testing board, which let you test your servo, even has potential of testing regular pulse width modulate controller servo. I think this is pretty cool. So if you're interested in anything like that, please check a link what I have down below, and I think this is worthwhile to take a look when you are building any robotic project, when you're using a whole bunch of these sort of servos. I think it's really useful. So this little board is the first version that I played with, and for smaller less powerful servos, and it's really good. This more powerful version with more powerful servos is actually even better. So I think I'm gonna wrap up on this one. There is not much else to say. Like this product, like the servos, like these testing boards, everything is pretty awesome. So guys, if you want to see more, please like and subscribe, comment if you have any suggestions and ideas, and see you next time on another episode of Inside Out Electronics.